And like basically, the problem that we would like to discuss is that the people who care about like foreign key performance, the main thing that we have discussed in past is that our use of triggers and maybe the discussion between about like row level triggers versus like statement level triggers, and like there have been like many discussions, but the one that I spent the most time looking at is our use of SPI being like the main uh, source of performance problems. And I kind of to prove that point, I wrote a patch, and I wrote it for a couple of like RI trigger functions, and the performance improvement is well twice. Like we get the time to insert a row into a referencing table or updating a referencing table can be cut into half. So yeah, there is some merit in like discussing like whether like removing SPI is a good idea, which I think it is. And if we do that, like what's the best way to replace what we have now, like what we should put in place to replace that. And yes, I wanted to gather some thoughts on that particular topic. The way the patch that I've written, I wrote a bare bones implementation where we just open up the index, the primary key index, for example, using index open, relation open, and just build a index scan struct and just start scanning it in that function itself. We don't do anything like, I don't know, use the executor somehow, like by creating a dummy index scan node and passing it to the executor function, things like that. So if we are to do this for more functions, maybe we might have to like think of something like that. Like writing a separate function, bare bones function for each case might not be a good idea. Or maybe like we'll have to do something else altogether. Like so like in some cases we might have to use the planner's capabilities, like for choosing between whether to do an index scan or a sequential scan and things like that. So we might have to get the planner involved somehow, and for which I don't have a very good idea at the moment, but I'm thinking about that. So yeah, I would like to get thoughts on that too, like whether like doing this using the low level functionality is a good idea or not, or we should replace SPI with something else, but that's higher level than what I have done so far. And Robert, if you want to add to that, yeah, please.
Yeah, I thought the central issue here was like, do we need to replace everything where we're using SPI, or can we replace some things, not others? And I guess like, when we talk about replacing SPI, I think what we're really talking about is replacing the use of the planner. So it seems to me, and maybe I'm thinking about this the wrong way, but it seems to me that like in the cases where we basically know what the plan has to be, or there are only a couple of choices, and especially where we can choose between the options without considering costing, then it's relatively easy to say, well, why don't we think about, bypassing the planner and jumping to, the strategy that we know that the planner would choose if we ran it. But in cases where the planner has a real decision to make, for example, because we don't know whether or not the column that we care about is going to be indexed, it seems like it's a whole lot harder to not engage the planning logic in that case, and might result in more duplicated code. Now, maybe it's worthwhile, because it always has seemed a little crazy to me that we do this kind of stuff by generating SQL query text and then feeding that through not only the planner but also the parser and everything. Like that just seems like a lot of overhead to be doing for a pretty fundamental feature of the system. But I guess my concern is that I would expect Tom in particular, but also probably other people to push back on the idea that we can skip the planner in the cases where we don't already know what the plan should be.
Okay, I have a couple of comments too. I mean, so I got sort of two ends of the spectrum. I can say a few years ago, I was working in the RI triggers source code, and I also ran into this, like, why are we generating SQL code? It seems silly, and I tried to convert it to so basically sort of a parse tree, basically like a query structure or something like that. I kind of experimented with a couple of variants and just said, like, instead of assembling an SQL query, you just create a query structure right away. And I didn't find useful, because it's basically more work or more code at the end than you had before. So it's more code, and you also then, the SQL code that is in there has been very stable, obviously, because it's just a couple select queries, nothing changes about that. But obviously the parse tree representation can change. So you have to then keep updating that if you make any subtle changes. So I would recommend against that. So that, and you're probably still not saving a whole lot, because you still have to then, if you were going that approach, you would still have to run the whole rewrite plan, execute everything, right? So that part, I think, is not useful. So then the other question is, skip the planner and go straight to some index scan. And I think there's a lot of functionality that is sort of contemplated, or people are interested in pursuing, that you do need a planner, right? Like, consider just everything about partitioning, foreign tables, views. That some of that doesn't actually currently work, but people might be thinking about that. There's also things like foreign keys that are not exactly equal queries, right? Sort of foreign keys based on sort of inclusion, exclusion, sort of temporal kind of stuff, where the reference is not by sort of equality lookup, but some kind of containment relation. So you do need lots of planning smarts, or at least sort of index choosing smarts and stuff like that. So I'm not sure that skipping the planner is, you can make a few cases fast, sure, but I think in general it's not something that can work as a general solution.
I got a couple of things to say here. One is that the reason that Emmett's patch didn't get merged in the past development cycle, at least in my opinion, was that it would have left us in a situation where there are semantic differences between some RI checks and other RI checks. Because of the different implementation technology. Now, we all know that there are quirks in the existing RI implementation, like you can cause other code to run after the RI triggers and undo their effects, things like that. And I think we'd all be okay with changing that and locking it down more, but I think it has to happen for all of them at the same time. So that was why I didn't want to, commit somebody that changed only one of the triggers. Another thing is that people were just ragging on the planner, but I don't think that's really the source of the performance problems, because we generate a text query and we parse it and we plan it, but then we cache that plan. So in my opinion, the performance issue actually stems from firing up the executor each time through, and that is the overhead that we want to look at getting rid of. And the only real idea I have for doing that in a general way would be to see if we can convert the RI triggers from being per row to per statement and rely on all the work that's been done on transition tables and so forth to amortize the costs more than we're doing now. I haven't spent any time looking into that, but that would be a direction I think would be worth pursuing.
But could we go deeper than that, right? I mean, could we go directly to the underlying machinery as a way of eliminating some of that overhead? Like, I mean, and instead of using node index scan, can we just like do index begin scan?
I guess, I mean, to the extent that we know that there are certain plan shapes that are likely to come out of this, you could imagine writing sort of a bespoke mini executor, but I think it would end up being a lot of code and a pain to maintain.
Yeah, we already have a bespoke mini executor for logical application. I don't know if you want another one. Want to get rid of that one?
Well, I don't know. I mean, I think it's just how much code do you end up with, and how much work is it to maintain, right? Like if it's going to be big, then we probably don't want it.
Mm-hmm.
It's not.
I guess this would call for some kind of testing benchmarking of where the actual overhead is in the, once the plan is cached, where does it come from? Yes, I was going to say this is where Corey comes in because of converting all of that to a statement trigger. You unmute.
Sorry about that. Yes, so I started 2 failed efforts to go to statement level triggers, and learned a lot, and also learned that statement level triggers are very, very heavy overhead. And that was a major reason why what little I got working was not very performant. And then, as I got into it deeper, it seemed like, okay, the per row aspect of insert triggers made perfect sense. And that led to the work that Amit's been going on, because basically those plans those plans don't benefit from set difference for the most part, especially if we have like the memoization cache, or that part, it could benefit from the plan in that we would have the previously looked up values memoized. But where the real pain in all of this is delete triggers. Is like, yes, the plan that the thing generates has the potential to be completely pathological, to basically do a sequential scan for every single row being deleted. And the problem is that there was no good way to know whether a row trigger or a statement level trigger was going to be better for this particular query. And kind of where, when I did this Unconference, I think 2 years back, the person who jumped in with the most interesting suggestion was Noah, and is not here today. But his take on it was that maybe it would be possible for the statement itself to remember the CTIDs of the rows it affected, and that would be a cheaper form of queuing than the transition tables, because the transition tables needed to store the entire row, not just the parts that were relevant to the to the referential integrity question coming up. So I didn't get very far with that, but I'm getting ahead of myself. That was an offshoot of the fact that I thought that maybe doing this stuff in triggers at all is the problem. What we need is to, at least in the case of immediately enforced triggers, is you just build these checks into the plan. And we add certain things like nodes that are effectively like left outer join, but it must fail in order to be able to do this particular operation. Or look up in this table, but any hit is a failure for the query. That sort of thing. That all seemed a little promising, but then somebody reminded me that triggers can be deferred. So that's the point where I had to give up on this effort, and fortunately Amit was taking over from there. So that's the end of the history lesson as far as I know.
Yeah, triggers already record CTIDs rather than full rows. So we know that that technology works. I hadn't really thought about the fact that transition tables weren't done that way, but seems like re-implementing them that way might be a worthwhile project independently of anything else.
Right, transition tables use tuple stores. So, and like in a recent project, I decided against using tuple stores and went with like storing the CDIDs. The project was the project to get the cross partition updates like working with foreign keys correctly, and for that I had to like make the trigger.c store like the two partition CTIDs, like partition CTIDs from like two different partitions, the source partition and the destination partition. Whereas I would like in an earlier implementation, I would like convert them to the root tuple format and store that in a tuple store. So yeah, the feedback like that Robert gave me was that not to go with tuple store because of the overhead of storing these tuples in full. And so yeah, like doing something with tuple stores, or we'll have to think about that aspect of storage overhead. I guess with doing things with like statement level triggers, we'll use transition table, which are tuple stores. So yeah, there might be the performance issue of using tuple stores at all. And Corey just described his project of switching from row level triggers to statement level triggers, which I actually had looked at the discussions like briefly, but I didn't really like spend a lot of time like trying to implement or like design patch around that. So yeah, I don't know, but yeah, like Corey also mentioned a possible idea of project to integrate the foreign key checks into the plan nodes themselves, rather than like using triggers at all. And yeah, I haven't thought about that a lot.
Don't you just need triggers anyway somehow? I mean, it doesn't have to be called trigger, but you kind of need some functionality like that because of the defer functionality, right? You need some way to sort of store up stuff to look at later and go back to it row by row or something. So just saying don't do it with triggers, it's just you're going to implement something like triggers. I mean, maybe that's, you can do a lightweight mechanism, I don't know, but it seems like not sure
like
if that.
Corey mentioned deferred, and yeah, triggers offer a way to handle that case, and that's that basically works. So like switching from trigger to something else has that hurdle, like to have something for the deferred case. And so I don't think I have any ideas for that. Like, yeah, let's continue using triggers, but make the trigger implementation more efficient.
I wonder if we could do anything similar to the way we are now doing uniqueness checks for deferred uniqueness checks. If I recall correctly, there's an initial pass, and if we see that the uniqueness condition is satisfied, then we're done. If it's not, then we queue a thing to recheck later. This is very hand wavy, but maybe we could make something of that.
Well, there's referential integrity triggers go in two ways, right? I guess the most common one is just the check that well, I guess Amit should maybe can explain like which one he's currently looking at, right? The one is that you check that the primary key is there, and then the other ones are the cascade and sort of the other ones that start from the primary key. So I don't know, which one are you looking at specifically?
The one I've implemented or a patch for is checking if a primary key exists in the primary key index. And the reason I went with that is because, as discussed before, like the plan in that case is clear. We don't have to like write SQL and pass through SPI and just get an index scan, like always get an index scan. That's not very clear in the other cases because the foreign key, the referencing table might not have an index. So, getting planner involved in that case is, yeah, it makes sense. Like doing it without the planner would be, that looks challenging. And yeah,
so can I just ask, like, how many plans are there here? So like you could have a single index that you need to go perform an index probe into, or you could have multiple indexes and you need to pick the best one. You could have a partitioned table, so you need to think about each child independently. And in some cases, you could have no index, in which case you're going to have to fall back on a sequential scan. Is that all the things there are?
Well, you do need an index, at least currently, right? Because it's a unique constraint has to be there.
On the referencing side, yes, you must point to a unique index.
I don't know if we ever want to allow deferred unique constraints on that. I don't know if that's even allowed, but I don't know. There could be things like global indexes at some point in the future. So I don't know if those run under index scan then at the end, or. But yes, you're right. Basically, yes.
I think
index scan or something with partitions is currently what you need.
No, I think you can need a sequential scan because.
But you have to have a matching index. No,
we repeatedly get complaints from people whose delete takes forever because they didn't provide an index on the referencing table and it falls back to sequential scan. Yeah, it's a well-known performance gotcha.
Yeah, you do need one for inserts. The constraint itself must.
Right, that's what we're talking about now. For the other ones, for the cascade and stuff, yeah, that's wide open.
Yeah.
But for that, you could have, I don't know, you might want to support partition tables or foreign tables or foreign key, what I mentioned earlier, for foreign key constraints based on GIS indexes and that kind of stuff that we might want to do at some point, right? So that, I think you need everything you can for that, but the lookup of the primary key is kind of the slow part, or the hot path, I guess, or whatever you call it.
Well, I mean, it's basically the same code that's handling both cases, right? Like you're either
currently more or less, yeah.
You're either looking something up in the referenced table or you're looking up something in the referencing table. And the referenced table has to have an index, but the referencing table does not have to have an index. And I think part of Tom's complaint is that he wants the semantics of those cases to be identical. So sequential scan is the relevant case because it happens when you're looking a row up in the referencing table. So the question,
we get away with eliminating that freedom and saying you have to have an index on the referencing table as well? I mean, it's going to break some people's setups, but I think most people would probably be happier if that constraint existed.
Like we ask in our documentation that having indexes on the foreign key columns in the referencing table is a good idea, but in the unique case, the DDL doesn't go ahead and create one, right? And maybe what would be best, I don't know if best, but is the foreign key creation, like creating the indexes as part of that DDL command, like as part of adding the foreign keys to a referencing table.
But I don't think you really need that because as was mentioned, right, you just need to have code for an index scan and one for a sequential scan. It's not that much extra code ultimately.
Well, so this is where I was kind of going with the question. It's like, if we want to handle all of these cases by bypassing planning, right? And maybe the executor as well, or whatever it is we're exactly trying to bypass here, like it's reasonably complicated because you have to choose among indexes You might have no index in some cases, and you might need to recurse to partitions, but it's still a lot simpler than the whole planner, right? I mean, you don't have joins or aggregates or tons of other things don't exist here, right? So like, is it bonkers to think about a mini planner that can handle that number of cases? Or is it a pretty reasonable idea? Yeah, let's have a mini planner. It'll choose between the indexes if there's more than one, which there probably isn't. It'll fall back to a sequential scan if there's no index. That seems pretty simple. And it'll recurse to partitions. That all just doesn't seem crazy. Like, is that going to be an uncomfortable amount of code to maintain, or is that going to be okay?
I think that's almost exactly the same code we already have for logical application. It sounds very familiar.
What would be the output of that mini planner? Would it be just an executor tree, same as we have today? I'm kind of wondering, what does that help us if the starting up the executor is the slow part?
Well, I think this is sort of, Robert was sort of saying, I forgot exactly how he phrased it just now, but you sort of said like something is making it slow, and do we really know what that is yet?
Well, what is the mini planner for logical replication output?
Well, it doesn't have a planner. It doesn't have a mini planner in that sense, because it just opens the table, looks if there's an index, writes into it, and then closes it. Right, so it's basically sort of doing replanning every time if you want, but it does have sort of that code of like, is there an index? You know, it looks it up by the replica identity, right? Is there a replica identity? Which one is it? Is there one? If there's not, look at the primary key. If there's nothing, look at do a sequential scan. You know, and then there's partitioning code in there as well. So it's this sort of same idea. It's like, I don't want to have a full planner. I have 3 or 4 or 5 cases I want to cover, and I'm just doing it sort of every time. I guess some of this could be cached. I'm not sure exactly to what extent, but it sounds very familiar.
Do we do this for every tuple?
I don't really know.
So the overhead situation is different between the insert case and, like, say, the delete case. We do store the plan for each, so you only plan it once. The problem is that the plan for the in the insert case, the act of the planning quickly became like 40% of the amount of time spent. And that's why it was so attractive to just get rid of SBI in the insert case. It's flipped in the delete case, where the plan is a very small amount of time, because in the pathological case, you're doing an index, or you're doing a sequential scan of a table to find a single tuple, and you're doing that for every row trigger. And there's, I guess we get the deduplication of those row triggers, but that's about it. And so you're looking at, potentially thousands of sequential scans of a table.
Do we do duplication of the checks when you insert? Like, if you insert 1 million rows and they all have the same key, do we check that key exists 1 million times? It seems like there might be some low-hanging fruit there for the common cases to have a little hash table cast there.
Can you repeat that?
So if you insert 1 million rows, do we perform 1 million checks against the primary key to check that? I mean, even if it's the same key.
Currently, yes.
Yeah, there's no optimization there.
So that would be one low-hanging fruit to add a little cast there.
Which is an argument for going to statement level triggers.
Yeah, that would be a more generic way of doing that. Yep.
So I just looked up the code. I guess the logical application does build the lookup every time from scratch. That could also be cached, but it hasn't been.
Yeah, I mean, I think like it feels to me like, so you almost, like, in terms of what the output of your mini planner would be, you need the OID of the index that you want to use, which can be invalido-id if you don't find a usable index. And then the only other thing you probably need is like maybe like, I don't know, an array of column positions in the index or something like
Yeah,
that.
it uses scan keys here. That could possibly be the thing, but you know.
Yeah, I mean, like it's something really minimal because there's actually so few things that you want to do here.
I think as found out there can be some asymmetry in the indexing in partitions though.
Oh, well, not asymmetry. It's just that to handle partition table, you have to look up the actual leaf partition and use its index, the leaf partition index. And that's the only complication with partitioning. And it's easy in this case because the unique key must contain the partition key, so you can use tuple routing to choose the correct leaf partition and use that table's index, as opposed to in a non-partition case, you just have one table and it's just use its index. And in the other cases, like we may not be able to use tuple routing, so the only difference would be there might be cases where we'll have to loop over all leaf partitions and scan them individually, which we don't have to do in this in the case that I wrote patch for the insert case.
I was still wondering what exactly is the slow part in the executor, right? There's something between calling the executor with a plan and actually doing the index scan that is somehow slowing us down here. And what is all that? I mean, obviously, maybe we don't figure it out right now, but that's probably something maybe that should be investigated with just a basic profile. And, maybe that's not something you can do anything about, but maybe there's some stuff that could be cut out. I don't know if there's like statistics being updated or some, because there's like other stuff too. If you do a cascade, a cascade delete, then whatever you're deleting from, you have to then also fire triggers, do all the checks, right? So that there's certain stuff maybe you can't escape. But I guess the primary key lookup, should be simple. And if there's overhead in the executor, maybe at least would be. I'd be curious to know what that is.
I mean, I don't know, but my guess would be that it just stems from the generality of the system. Like the executor. If we go and look through an executor state object, right, it's got a bunch of things in there. And when you go to initialize the executor, it doesn't know which of those things your plan is going to use. Now it can defer initializing things until they're used in a lot of cases, probably. But you're going to need target lists, and we don't really care very much about the target list here. And like there's a bunch of things, right? And even the if statements that you don't end up taking still end up costing you something by just existing.
Yeah, sure.
I mean, I don't really know specifically what's going on here, but like, if you think about running select count star on a table, and then you think about writing a C function that just does a begin sequential scan and loops over all the tuples and a heap end scan, and increments an integer variable or a UN64 as it does so, like it's going to be massively faster. And you can sort of see why, because there's all sorts of things that you're not doing. And some of them are things like overflow checks and stuff like that. But a lot of it is just you're not bouncing around to all different parts of code and testing lots of conditionals that you don't care about and doing all of that stuff. You're just doing the essential work. And my intuition, which could be wrong, is that this is the same kind of situation, that it's just that there's just a bunch of general stuff that you're not doing, which is maybe not very costly in terms of the individual things, but there's just a bunch of stuff because the executor is complicated.
Yeah, I had a thought about that. We already said that we're caching a plan, and therefore, at least theoretically, the planner shouldn't be the issue here. But what we know we are doing is every time through the trigger, we're initializing the executor and shutting it down again. And I wonder if we could cache that ready to go executor state tree and just run it for another row each time through the trigger.
Sounds a lot like evil plan qual.
Sorry?
It sounds a lot like the evil plan qual stuff.
Oh, yeah, that's stuff.
The evil plan qual stuff?
Eval plan qual.
Oh, no,
Recheck stuff.
I'm pretty sure the correct pronunciation is evil.
Well, I won't argue with that. Anyway, I have no work offhand, but it just seems like that might be a direct way of attacking the overhead without fundamentally changing things.
Yeah, maybe. I don't know.
So like Peter mentioned the cascade case, that it's difficult to imagine handling it without having the executor involved in, and I was thinking of like adding something like restricted APIs of exec update and exec delete to be called from here to handle the cascade and set actions, like just like the logical replication has restricted forms of, for example, exec simple insert, there is exec simple update. We could have like, maybe we could refactor and use similar functionality. Like we just basically want to delete or update a given row, and we don't maybe need the whole executor e-state for just doing that. We could,
the logical application code does have support for firing all these triggers and all that stuff, right? So that's not the reason why those. I mean, I think my recollection is actually the separate executor code for logical application basically just existed because it was too hard to do it up better, right? There's no performance reason or anything like that. It was just easier to do it that way, really, than integrate it into the whole, node modify this and that, which maybe now is worth another look after it's been refactored a little bit for merge too, and not something I would necessarily recommend doing, but or sort of that's not a reason to do it, right? I mean, it's maybe still worth doing this sort of mini executor that we're talking about, but the existing one is not for that reason.
Is there any chance of sharing that mini executor between logical replication and the RI stuff?
I mean, again, what I meant is the logical application stuff, if somebody wants a project, it could actually be gotten rid of, I think. You just have to generalize the other code and call into it instead of, there's no reason. It's just a pain to keep it updated, basically, right? Every time like the trigger API changes, you have to update it in 2 or 3 places instead of just 1 or 2. And, it's not a good experience, really. But if we do that, yeah, there's probably some similarities. But then again, I don't really know what is I don't have that sort of ready now because it's been such a long time since I really worked on it. But it's like, what is the difference really? Like it supports everything, right? I think the only thing it really doesn't support is sort of foreign tables. You can't insert into foreign tables from logical application, which is probably rather a deficiency than something desirable. But it supports triggers, it has to update statistics, and it supports cascading. And so there's nothing, it's simpler in a way that it doesn't support certain things, but it has to do all the things. It has to support partitioning, it has to support statistics, it has to support before, after triggers. And I don't know if it supports statement triggers, it might not do that, but so it's not clear to what degree it is actually simpler right now. Maybe it initially was simpler because it did support partitioning, for example. Again, there was a deficiency in Postgres 10, not something that was intended. But now I don't think it's really simpler. It's just another version of doing the same thing.
Yeah, so right now those functions are in what a file named exec replication.c. I don't know, maybe we could refactor it to be exec common insert update. I don't know, like something like that. Like it's being advertised as for use by logical duplication, but and yeah, the RI case, the cascade and set routines will need not more any more functionality than what logical duplication workers use. So yeah, I think that so we can like yes, keep using
if you
the whole
get
executor.
if you get to a point where calling those functions gives you the same performance benefit, then calling index scan directly, yeah, then that's great. Then I think we can generalize it. I just at the moment I don't know where that performance would come from. I not because I doubt it. I just don't know. So don't think because it says simple, it's somehow faster, right? It's just simple because simple stands for I was too lazy to do it properly. or whatever you want to think of it. Some of those reasons have been lost over the years too.
It's an interesting idea to try to share that code. And I think Tom's idea of whether there's a way to keep the same executor tree around and just reuse it is also kind of interesting. I feel like there might be some issues there with like memory context lifetimes and crap like that, but I don't really know. I think it's something to think about at least. Another question is like, how much overhead do you eliminate with these various techniques? And then on the other hand, how much code complexity do you add? Like it might be, I mean, if we found that actually keeping the executor state tree around is something that we can do with a small amount of code and it gets almost all of the available performance benefit, well, then that looks pretty good. If it takes a bunch of ugly code and it only gets 50% of the performance benefit, then I think that's not really getting us where we need to be. But it's kind of hard to know that without playing around with it.
Yeah. I assume that at some point somebody's done some profiling on all this. Do we know what the results look like?
I did.
It sounds like it's not. Oh, you did, yeah. Okay.
I did some very, very unrigorous profiling with Andres on a pair programming thing we did, and that conclusion of which was, gosh, we spend a lot of time doing all this SPI stuff, and that was the end of the conclusion there. I did have one question and one thought to possibly add. The question is, would it benefit us if, say, just the syntax tree of the triggers was stored on the constraint itself? Because that would save something, because that action is pretty deterministic. Obviously, it would have to be like recomputed after any DDL that affected either table, but that's a pretty minimal amount of work to save, millions and millions of string reconstructions and plannings.
But I think it's being stated we're not doing that anyway because of the plan cache. Am I wrong?
But well, I mean, we cached the plan, but I wasn't thinking of millions and millions of rows for this particular one. I'm thinking of the millions and millions of times that a connection inserts a row into this table or attempts to do a delete. The other part was that would it be like a smaller lift to reconfigure how statement level triggers accumulate the rows instead of using a tuple store? We talked
about that earlier, right?
But would that be the smaller lift here?
Well, I was attracted to that idea mainly because it would make all uses of statement triggers faster, not just RI. So I think that's very possibly a worthwhile project independent independently of this.
Okay. Well, because if that happens, then we can kind of take what we've got now, switch everything over from row level to statement level triggers and call it a day.
It's kind of hard for me to imagine how that captures the performance benefit, but maybe my imagination is lacking.
It probably doesn't capture the performance benefit in the insert case, which is why Amit's work on the insert case was so promising.
Then we're talking about like two separate implementations having be present at the same time, and which Tom was initially complaining about, like having two different things going on for two different cases. Like,
So Tom, can you say again, and maybe a little slow, like I'm dumb, like what exactly is the semantics difference that you think Amit's patch introduces? Because I got that you had a concern there, but I don't think I understood exactly, like what exactly is the problem there?
Well, the concern I had, I don't know that there were actually bugs of this ilk in the final submitted patch, but for example, when we fire up the executor, it runs around and it does privilege checks, right?
Okay.
Is that replicated in any replacement behavior? Do we need it to be replicated in any replacement behavior? I don't know. But I would be unhappy if some flavors of RI performed privilege checks and others did not.
That does seem fair.
And you can just run down the list of things that happen in the SPI execution chain and say, well, are these still going to happen in the replacement code? And if not, is that a problem? So that was why I was big on replacing it all at once and not doing it piecemeal, because if we say, well, all right, we've determined that we're not going to do privilege checks in this path, and that is now a uniform policy, I'm okay with that kind of change. I'm just not okay with, well, some behaviors will do it and some won't.
Yeah, that does
And
seem.
you have row level security possibly in there.
Yeah, RLS is another big one here.
SE Linux things.
But like, is this sort of a hypothetical concern? Like we don't know whether we have any issues in there, or is this like a demonstrable concern? Like we definitely know the patch did the wrong thing.
The initial versions of the patch definitely did the wrong thing. I don't know if Amit fixed that along the way.
Okay.
Right. I think you mentioned the things that you just mentioned on the list. You mentioned the privilege checks, possibly being done differently, and you mentioned RLS. I think we agreed that our RLS it doesn't matter in this particular case. And so that was that. And you also brought up some issues with snapshot setting, the way snapshots are being handled. Like, but in the patch for inserts, like we only need, for example, the cross-check snapshot that we have, that the update table update needs to look at that is being passed through SPI, but they were not being passed in the bare bones implementation. Like, so I think we left the discussion there, like is the snapshot behavior entirely identical with the SPI implementation and the bare bones implementation? Are we sure that, like, for example, scanning index directly is fine, but like the user functions present in index access method might expect the cross-check snapshot or test snapshot to be set in a certain way, and by just dropping out the cross-check snapshot, maybe we're just like disregarding that question. Like, so I think the snapshot handling was something that kind of got left hanging in the air, and we just left the discussion there. But the other concerns.
Sorry, go ahead.
Yeah, so the other concerns about the privilege checking and RLS were, I think I addressed them for for the insert case. But yeah, like we'll have to make sure for other cases we'll have to do the same thing, maybe refactor code to use have a single copy of how the privileges are checked for any checks like so. Yeah, so right, like so semantic issues like only the snapshot ones are, I think, a bit unclear at this point.
One thing you could do with that is sort of cut out SPI and just call whatever SPI was calling, sort of still call the planner executor, right? But sort of bypass the whole SPI API. And then you get out of these, sort of particulars of how SPI manages snapshots in certain cases and sets, and then you might also save a little bit of the overhead of sort of the extra memory context stuff and all that stuff that SPI does, which, SPI is sort of an interface for user-facing things that you don't need internally. So you could maybe just cut. I mean, it's not going to give you the sort of performance improvements that you're ultimately looking for, but you sort of cut out.
Yeah, I mean,
something that's in the way, and you can do it all at once, right? And then you sort of move from one snapshot behavior to another snapshot behavior, settle on that, and then you can start refactoring stuff after that.
Yeah, Andres was actually telling me at some point that he thought we should remove SPI from the system completely, basically because it was a complicated piece of crap that never did what we wanted, which I was very surprised by. But I kind of see his point. It feels like we spend a lot of time struggling with things like, well, where exactly do we put which SPI calls, and every time I try to do anything with SPI, I always end up leading SPI.c to figure out which function it's calling, and then I call the SPI function that I need to call in order to get it to do what I really want, which does feel a little ridiculous.
Which sort of supports the idea of maybe just cutting out SPI in this particular case.
Yeah.
Without a whole bunch of rewriting of the triggers and stuff. Obviously, those are all other additional projects to consider, but just cutting out, instead of calling SPI prepare plan, you just call the planner directly.
Well, I mean,
if
it turns out that that's something that's easy to do as a first step, and it is something that we can agree on makes sense from a semantic point of view, and it's at least no worse and maybe a little better from a performance point of view, if we can knock it off quickly, then it makes sense. But just historically, it seems to often end up that for whatever reason, emits patches are going in, right as we're up against the end of the release cycle. I don't think it makes sense to spend an entire release cycle to just do that. But
no. I mean, that
if we could do it in August,
hopefully,
then, if we could do it in August as a preliminary step, then yeah, great.
Yes, that's the way I would think about that.
I find it hard to believe that is going to get us very far in terms of performance. I mean,
no, but it removes
SPI is a pretty
sort of one
thin
level of
wrapper
concern.
around the stuff that it calls.
But it has all these like snapshot handlings in the middle, right? That it sort of handles for you. And if you could remove that and set the snapshots in exactly the way you want, and then you sort of nail down those semantics. At least that's my thinking. I haven't
most of the weirdness around snapshots is actually stuff that we shoved into SPI because RI triggers needed them. I mean, that complexity doesn't go away. The semantic need for that doesn't go away if you get rid of SPI. It's inherent. I don't remember exactly why it's there, but it's inherent in the RI problem.
Yeah, I think just removing SPI as a first step sounds like a good idea. And like you mentioned, profiles, what we see in the profiles, I see SPI underscore functions a lot in the top, 20 or 30. So yeah, there might be some performance benefit of just removing SPI. And the most important one is, I think, getting the issues around semantics. I think they will be easy to handle if we remove SPI as the first piece we remove. Then we passing the snapshots directly to the executor, and it might be easier to replace that with something else. SPI, I have to go to SPI and see what's the default behavior is, when they're not said explicitly. So there's like have to do like jump back and forth, and that will be gone if we remove only the SPI. So I agree with removing SPI as a first step would be a good idea.
Yeah, it's worth a look.
It may not be the right idea.
If it,
But it may not be the
if
right
it takes
idea.
3 months, obviously it's the wrong idea. But if it takes a week and everything looks cleaner afterwards, it's worth it, maybe.
Yeah. At least worth checking. We are kind of at time. We're not quite at time, but we're very close to being at time.
Yeah. So yeah, I think this was a very useful discussion. I heard a lot of useful ideas to if the last one, the SPI one, you can just go ahead and start looking at it. So yeah, I think I don't have anything more. So yeah, thanks.
Took a bunch of notes
coming.
here, which I will type in later.
Oh, great. I was wondering if someone was taking notes.
Yeah,
I have some of my own. I'll just look at Peter's and see if I can add some things.
yeah, it's.
I guess you
basically,
write them to the wiki, right?
Yeah.
Wiki page. Okay. So I'll take a look at that.
Yeah, there's someplace you're supposed to put the notes from these. Stan, do you know where? I don't think he's listening.
No,
So
it's
there's a
in
wiki
the normally we link it from the wiki, so we'll figure that out.
Seems like a solvable problem.
Yep. Well, there is a solution, standard solution is my point.
Yeah.
All right. Thanks, everyone. I guess.
Okay, thanks.